Hey everyone, and welcome to The Year Was, the podcast all about today that gives you just enough information to effectively be that guy at the party causing all your friends to question, hey, who invited you? Like, seriously, why are you here? I'm your host, Michael Montalvo, and for the next few minutes we will swim through the river of time to try and find out what makes today truly unique. In this episode, we examine the events that occurred February 9th. Look, there's no use in denying it. I'm getting old. In fact, a favorite saying of mine is that if you are only as old as you feel, I must be around 80, give or take a few years. And there are lots of things that get old, jokes and corn and such, but there are also objects out there that are so old, we cannot even begin to comprehend what the word really means or how old an object really is. And one of those things are stars. Stars are power sources. They power life, they give light, and they burn with the power of, well, stars. But even with all they do and all they are, they still start life very small. Just particles of dust and gas floating around in the presumably endless vastness of space. The website How Stuff Works describes them as nebula that are cold and monotonous, just stars that are inactive for ages before finding that one thing that changes everything. They compare it to a sleepy town that is stirred into a frenzy with the arrival of newcomers. So what can cause this change? Anything, really. Comets, supernovas, shock waves, Eternals, Galactus. A burst of energy will move its way through the clouds of dust and Alderanian debris and form clumps that form bigger clumps that turn into Nutty Professor 2, the clumps. Joking aside, these clumps start to get bigger and bigger until they start to create their own gravitational pull and begin to pull in more and become stronger. And then, in what is truly an act of patience over millions of years, the star draws in gases, becoming a baby star, a protostar, and it becomes so hot that even Paris Hilton would think that it's hot. With its growing heat, atoms begin to fuse together, and then atomic nuclear fusion happens. Hydrogen atoms fuse together and become helium. And then it just keeps going until it doesn't. At some point, it stabilizes and reaches a point where its output is more than its intake, and this is when the star is kind of born and when it starts to die, because it will only last as long as it has fuel to burn through. Now, I know some of you are thinking about the start of the universe and the whole religion of it all, and while this is a valid topic to bring up, we will not be discussing it here today. What we will discuss is the discovery by a team of Australian astronomers. The year was 2014, and on this day, February 9th, astronomers at the Australian National University discovered the oldest star. The team, led by Dr. Stephan Keller, found the star to be approximately 13.6 billion years old, which is a staggering number to think about unless you think about the age of the universe. And even then, maybe not so much. The Big Bang is thought to have happened 13.7 billion years ago, and so the star formed right after the Big Bang event. The discovery of this star has given us a chance to study star chemistry. It's a look at the infancy of the universe. Keller would even say, this is the first time that we've been able to unambiguously say that we found the chemical fingerprint of a first star. So how does one determine a star's age? Well, it's all estimations, really. Based on spin and brightness, scientists can determine approximately where a star is in its life cycle, and then determine its approximate age. And they use other stars to do this. Stars in the same area were most likely formed around the same time, and so while larger stars use their energy faster than smaller stars, it may be in different points in their life, they can still be around the same age. The best we can really do at the moment is to look at all of these factors and sort of ballpark a number to determine its approximate age. Now, as with anything I do a topic on, there are some questions and discrepancies. There is a star known as the Methuselah Star that is supposedly 14.5 billion years old, which would make it older than our universe. The question here is, how can this star be older than the universe, and also, how many universes are there? If you're interested in more space topics, we have a few episodes on the channel, including one where I discussed Hubble with Matt and Tim. As you know, with that telescope, we have found some amazing things. Images filled with specks of light that are stars that would have had to travel millions and millions of years in order to get to us here. So check that out if you're so inclined. That's going to do it for us today. If you like this podcast and want to hear more, give us a rate and a review. That helps me out and helps steer us in a direction that is hopefully good for all. If you're watching this on YouTube, you can find the Year Was audio version on your podcast app of choice. You can find me on social media and at YouTube at the Apple Cider Club. And as always, I want to thank the Tim Kreitz Band for our musical theme. And thank you for listening. We'll see you next time.